Welcome students, today we will be learning about karst topography. In that, we will be dealing with the chapter Mechanics of Groundwater, Erosional Landforms. Karst topography is a combination of unique features that make it distinctive. It is a result of many geological processes, especially the dissolution of limestone. Sinkholes, caves, polges, ualas are few of the erosional features of the karst landscapes. These features not only alter the geographical characters of the environment but also impact biodiversity and hydrology. This highlights the importance of studying the erosional landforms that form a karst topography, for they hold significant ecological and geological value. Objectives. After going through this class, you will be able to understand the overview of karst topography, erosion and karst, the resultant landforms, importance of erosional landforms. Let's now first understand the conditions essential for the development of karst topography. To summarize, the following 4 conditions are prerequisites for the formation of karst topography. There must be a presence of near surface soluble rock, preferably limestone. Secondly, the soluble rock preferably must be highly jointed, dense and thinly bedded. Permeability is favoured by numerous joints and bedding planes. It is favourable. Thirdly, existence of entrenched valleys below uplands underlain by soluble and well jointed rocks. The region must receive a considerable amount of rainfall, at least moderate amount. Now the question arises, what is erosion? Erosion. It is an acting wearing away of Earth's surface by moving agents like running water, wind, ice and waves. Karst topography is largely formed by denudation processes of weathering, especially chemical weathering. For example, solution, porosity and permeability are the 2 driving forces of topographic design in the karst regions. Porosity depends on how easily water can pass through the rock structure, and permeability depends on how easily the absorbed water can move around in the rock structure. Let's now understand the types of erosional landforms in karst regions. Erosional landforms are the most profound features developed in the karst ecosystem. Sinkholes, caverns and ualas are some of the main examples of erosional landforms. They are found by the collapse of surface material into voids created by groundwater erosion, leading to varying depths and diameters. Caverns, on the other hand, form through prolonged chemical weathering of limestone, resulting in intricate underground systems that are characterized by stalactites and stalagmites. As noted, karst landscapes are marked by several erosional features, including caverns, sinkholes or dolines, ualas, karst window, polges. Terra rossa. It is defined by surface and near surface solution by descending groundwater, which usually leaves a residue of red clayey soil mantling the surface and extending down into open joints. This material may be lacking on steep slopes. It is present on moderate to gentle slopes. It may vary in thickness from a few to many meters. It can completely mask the rock surface. Terra rossa resembles in appearance to the lateritic soil of the tropics, if indeed it is not a species of it. However, it is by no means limited to tropical or subtropical locations, being found as far north as southern Europe and southern Indiana. The next feature, lapis. Locally, where relief is considerable, limestone surfaces are bare of terra rossa, and there is exposed and etched, pitted, grooved, fluted and otherwise rugged surface to which the name lapis is most commonly applied. A variety of lapis in which the solution grooves are rather minute and closely spaced has been called rill lapis, which is a German name derived from Nenkeren. Sesevik has described and pictured the amazing diversity of surface and form which lapis exhibits in the Dalmatian karst region. He maintained that lapis is found chiefly on the outcrops of naked rock and pointed out the influences of such factors as rock composition, texture, structure, surface, slope and amount of vegetation upon its formation. He further claimed that it was rare on horizontal rocks, being replaced by sinkholes. Others have argued that it develops under soil and vegetation cover and is exposed later by erosion, accelerated perhaps as a result of deforestation. Lapis surfaces are rarely seen in the Indiana-Kentucky karst area, but where the terra rossa has been removed, we find a surface exhibiting most of the characteristics of true lapis. It is the best portrayal of how minute differences in rock solubility, permeability, jointing, bedding and other physical and chemical attributes can influence the rate and localization of solution by descending meteoritic waters.